Hello, welcome to part two of a three-part video where I'm going over how to solve complex exponential and logarithmic problems. Again, definitely go back to part one where I made sure I showed you all of these rules, like for instance this one, when it comes to taking the log of both sides to help you solve sometimes exponential and logarithmic problems. So you really need these notes because we're going to be using a lot of these rules while we solve these two problems in this video. And then you'll see two more complex problems in video three. So let's get started. So when I look at this problem, I notice that my exponential base doesn't have the same number. And on top of that, it actually doesn't have numbers that I can change one into the other to make the same base. So I need to look at my other rules in order for me to solve. And one that helps me a lot of the time is actually taking and placing a log into it so that I can use its rules. So I'm going to take the natural log to both sides, and I could have took the log. It's just as long as it's the same one, but natural log is shorter to write, so we oftentimes use it. And so by me doing that, now I can use some of the logarithmic properties to try to help me isolate this x value. Excuse me. So for instance, immediately I see that I have an exponent, so I can use the power property, which means, and again, power property is part of these rules that I told you about. But that property says I can take the power and actually multiply it to the logarithm and without changing its meaning. So now I can write 3x minus 1, and I'm going to just place it in parentheses so that you can see that it is being times natural log of 4. That these two things are being times, not necessarily that they run it together. And then equals, parentheses, 2 minus x, close it, natural log of 3. So now the trick to this is I got to think about natural log of 4 and natural log of 3 as being real numbers rather than letters and numbers. And so when I remember that it's a number, then I just think of it like the way I solve equations. I distribute, I get the letter on both on the same side, and then I can solve. So I literally can multiply this natural log of 4 to this and to the negative 1, and same with the natural log of 3. So what will happen is I'll have 3x natural log of 4 minus natural log of 4, and then on this side equals 2 natural log of 3 minus x natural log of 3. Now I need these x's to be on the same side, and I need these numbers to be on the same side. So I'm going to do algebra. I'm going to add the x and move it over there. I'm going to add the natural log of 4 and move it over here. So I'll have 3x natural log of 4 plus x natural log of 3 equals 2 natural log of 3 plus natural log of 4. So I have my letters on one side, I have my numbers on the other. And both of these have an x inside of them, so I can factor it out. So I'll have x times 3 natural log of 4 plus natural log of 3, and I close my parentheses. And then over here, to make it simple, and again, just kind of simplifying it, putting it back into a power look, so I'll have natural log of 3 squared plus natural log of 4. Okay, I know y'all like, whoa, Ms. Norfolk. It's okay. We're still just constantly doing properties, and remembering these are numbers inside of it still too. So again, I'm going to combine these into a property. I got power with the 3 being in front, but I also have a product because it says plus. So I'm going to say x parentheses natural log of 4 to the 3rd power, and then that's times 3. So these two can really be multiplied together. There's 4 and 3, but the 4 really had a to the 3rd power on it. And so now I have equal, and again, since I have a plus over here, I got the product property happening. So the 3 and the 4 really could be multiplied together. But I also really had the 3 squared. So 3 times 3 is 9, but then 9 times 4 is 36. So I have a natural log of 36 on this side. And now I can divide, which this on the inside is really natural log of 192 equals natural log of 36, because again, 4 to the 3rd power times 3. And now I can divide by the natural log of 192, divide by the natural log of 192, and when I put that in my calculator, it'll say it's about 0.68, because we usually go to 2 decimal places. So a lot more rules going back and forth in this one, and trying to figure out how I can get the x by itself so that I can then solve it. Okay, let's go to one more complex one. This is still dealing with exponential in its form, but now I have sort of this unique situation of the exponents, the base being the same in certain instances, but I have a lot more terms. So in this situation, I don't have things on one side or the other. I have numbers and bases mixed together. So I need to think about some rules that I have from my multiple term days to see what I can do. So if I have a multiple term, meaning I have more than just 2, and it has powers, I need to see if happen to be one of the powers is bigger than 1. And it is. This one has 2x. So that's always going to be bigger than 1. So I could possibly use quadratic or solving by factoring principles to actually have it happen. And to help me out, a trick sometimes math people do is to simplify the process. We'll replace all these letters and numbers with just one letter. So I'm going to actually change the e to a u, the e to the x power to a u, so that I can simplify this process. Okay, so when I replace the e to the x with the u, I go ahead and put it in the equation and then treat it like I did in Algebra 2. So it would be u squared, because the ex went away, but the 2 stays there, plus 6u minus 16 equals 0. Now, again, like from Algebra 2, this looks similar to x squared plus 6x minus 16 equals 0. So I'm literally going to factor and solve like I did in Algebra 2. So I'll have 2 parentheses, a u and a u, because that makes u squared. Then I got to think of what 2 numbers multiply and give me 16, but add or subtract and give me 6. And I come up with 8 and 2. The 8 is going to get the plus sign because the 6 is plus, and the 2 will get the negative sign. Now I separate and solve. U plus 8 equals 0. U minus 2 equals 0. Or U equals 8. U minus equals 2. Again, I can't have, I'm sorry, negative. I can't have just the u. I have to replace it back with the e to the x. So e to the x equals 8, and e to the x equals 2. Now I can work with this, but I still have that same challenge where I can't make the bases the same. So I'm going to take the natural log of both sides to solve. So natural log of e to the x equals natural log of 8 natural log of e to the x equals natural log of 2. Now, this is one of those properties where I immediately recognize it's just the power. So x equals, oh, look, negative 8. I keep forgetting to bring the negative 8 down. Natural log of negative 8. And x equals natural log of 2. Oops, sorry. It's not a square. It really is next to it. So it's 2, 2. Okay. I checked my solutions. This really can't happen with a negative number, but I can have this, which is about 0.69, and so this is my answer. And that concludes our complex set of problems for part 2.